Hi everyone, this is the OS project EP, and in this section we want to know how to debug kernel functions. And before we start it, we need to disable the KASLR by using this quiet no cancellor so that we can set breakpoint when we are connect remote GDB. After we add no cancellor in a line, we need to update the graph. And after update the graph, because we want to connect remote GDB, we need to add kgdb weights and kgdb OC equal ttys1 11520 back to list. By doing this, we can use the remote connected. As we mentioned before, we want to set breakpoint when we are connect remote GDB. So we need to see the kernel function that we can use. And here is the kernel function of our machine. There are much more kernel functions that we can use. For example, the pause kernel function is in the kernel signal.c. The nkdir kernel function is in the fs/name.c, and the state kernel function is in the fs/stat.c. Here we connect the host machine to the target machine by using gdb target remote/dev/ttys1. Now we create a breakpoint with this command, which means that when we create a file or folder in the target machine will be freed. And every time when we type continue, the target machine will unfreeze. And you can see here, we create a new folder in the desktop of the target machine, and we can use this command print pathnet in the host machine, and you can see the new folder we create, the path of the new folder we create. After we keep typing continue, the host will already pass all the continues, and the target machine will be unfreeze and with the new folder created. Here is our exercise of session 1. We open the host machine and the target machine first. We choose the rename kernel function as our breakpoint. First we can see that the function to trigger is the do-rename at 2, and to trigger it, basically just rename any file or folder in the target machine. Like this one, we create a new folder in the target machine, and at this time the target machine will still working. But when we rename it into a new name, for example, in here is 123, the target machine will be freeze. It will be unfreeze until we type continue. And furthermore, you can see the parameter of the rename function we mentioned before, like the old name is here, new name is here, the old DFD is here, and the new DFD is here. And similar as the example before, we need to keep typing continue, and after it went through all the continues, the target machine will be unfreeze. Here we step in the session 2. In session 2, we want to know how to fulfill kernel function. and we need to install the required tool. Like for example, is a perf tool we need to use, and here is all the perf commands we can use. Here is the example to show us how to use perf. Like here, we create basically an empty.c file, and we use the command sudo perf record and sudo perf trace to execute this file, like here. And we can see the every step that time is spent, and another one is the file copy test. Basically, this is to copy a file into our folder, and as you can see, that is also calculate the spending time of each step. I compare this to records from the empty test and the copy test, and we can see that the copy test has more record like the clone, open, f, state, and so on functions, because in empty test we didn't use this, and in copy test we need to copy the content, and this is the extra steps we need to use. Here is the questions we need to answer. First is what are these functions? Clone and map, write, and open. First, clone is just like it's really similar to fork. It creates a new process, and we will compare clone with fork in the second question. And map is like mapping a old address to a new address. It creates a new mapping in the virtual address space of the coding process. And write is really is similar as we write as a write in our programming. It is write out to count bits from the buffer point path to the file referred to by the file descriptor. Open is to open a file, and it establish the connection between a file and a file descriptor. The second question is the difference between fork and clone. Fork is also create a new process, but it create a new process by duplicating the code in process. But in clone, it create a new process, and it allows the child process to share parts of its execution context with the code in process. To be sure, this clone share the data memory, but fork is not. And will the function's execution time be longer if the file is bigger? And to answer this question, we need to see our screenshots here. And by doing the procedures in the PDF file the teacher gives us, we can see that when the file size gets larger, the average execution time gets longer. And the fourth question is to compare each execution time between different functions. And as you can see, the slowest function is the open function, and the second is the mmap function. The third is the clone function, and the quick function is the write function. And the last question, and teacher asks us to choose another commands to use and explain how to use it. And I choose a command perf is also the everyone usually use. And this command generates and displays a performance counter profile in real time, and it can operate in a mode similar to the Linux tab tool. Like you can see in the screenshot, it will keep showing and displaying the performance for of our machine in real time. And here in this is a normal situation. It spends most of the time in the kernel, and it will keep showing this until we type Q to exit. Now we have now the basic to use the perf tool, and there is also a command that perf has is a sudo perf reports, and the function of it is to display the performance counter profile information record via perf record. And you can see the example for file copy test. In here we can see that basically all all the tasks of the kernel is by doing the file copy test exe, and which is reasonable because when we when in the previous screenshot here, we are calculating the execution time of different file size, and because we need to calculate it, we need to execute a file copy test, so it is reasonable. And this is all the tasks and questions we do in the project EP. Thank you.